7.4, we're looking at double angles and half angles. So this first video will be about the double angles. The double angles. So cosine has three different formulas that you can use. You can use any of one of them. All right, and so maybe this first one you might use if you're given cosine of an angle and you're given sine of an angle. This one you might use if you're just given sine of an angle. And this one you might use if you're just given cosine of an angle, right? And so what this means, this is a double angle. So I take 2 times my angle, and then I take the cosine of that. That is not the same as 2 times cosine of A. These two are not the same. This is saying I take cosine of A, cosine of an angle, and then times it by 2. This one right here is saying you take 2 and you times it by the angle first, and then you take cosine. Okay, so make sure you know the difference on that. Then sine of a double angle and tangent of the double angle just have one formula, and this is multiplication. All right, so this is 2 times sine of A, cosine of A. So for this one, you need to find sine of A and cosine of A in order to use that formula. This one can be nice because you can actually use this formula. So tangent of 2 times A is the same as sine of 2A over cosine of 2A. So if you figure out these two, sine of 2A and cosine of A, then you can figure out tan of 2A. If not, you would have to find tangent of A. So you have to find tan of A in order to use this formula right here. Okay, but if you know sine of 2A and cosine of 2A, then you can use the quotient identity for tangent, right? Tangent is sine over cosine. Okay, so let's go ahead and do a couple examples here. So here's example 1. You're given cosine of an angle is 3/5, and that sine is less than 0, which means sine is negative. Okay, and we want to find sine of 2A and cosine of 2A and then tangent of 2A. And because we're finding these two, all right, that means this last one we can rewrite as sine of 2A, or theta, over cosine of 2 theta. So we could use these two that we just found in order to find tangent, or we could go ahead and find tan of theta and then use the formula from the last slide. Okay, so first we can find sine of 2A. So sine of, or 2 theta, because our angle is just theta, is 2 times sine of theta cosine of theta. So in order to use this formula, we first have to find cosine, which we do know, right? Cosine of theta is given to us of 3/5. Now we have to find sine of theta. Well, sine of theta and cosine of theta are related with the Pythagorean identity, right? Sine squared of theta plus cosine squared of theta equals 1. So we can rewrite that and solve that for sine of theta. And that is the square root of 1 minus cosine squared of theta. So that means I got to square my cosine, which I do know is 3/5. So I'm going to square this. Then I'm going to subtract 1 from it, and then I'm going to square root that. Okay, so that's 9. Oh, that's a 5, not a 2. Sorry. So that's 9 over 25. And then I'm going to take 1 minus that, and then I'm going to square root it. So 1 I can rewrite as 25 over 25. Then minus 9 25ths. So now we have a common denominator. So we get 16 over 25, and then I square root the top over the square root of the bottom. And that is 4 over 5. And then we know sine from our directions that it's going to be negative, right? Because sine of theta is less than 0. So now we know sine of theta is negative 4/5, because it says sine is negative. So we know this sine, write it backwards, sine of theta equals negative 4/5. So now we can use this formula of sine of 2 theta. It's 2 times sine of theta cosine of theta. So it's to find sine of the double angle of sine is 2 times sine of theta cosine of theta. So 2 times our sine, which is negative 4/5, times our cosine, which is 3/5. So this 2 is in the numerator, right? So we can multiply all our numerators. 2 times negative 4 is negative 8. Negative 8 times 3 is negative 24. And then 1 times 5 is 25. So then that means sine of 2 theta, or the double angle of sine, is negative 24 25ths. So that means we have the double angle of sine. So that's step 1, right? We found that, part 1. Now we want to find cosine of 2 theta. And cosine of 2 theta, we could use any 3 of these formulas right here. right? So probably this last one we're going to use because we have cosine, right? We're given cosine. We could use this second one because we found sine, or we could use this top one because now we now have sine and cosine. But we'll go ahead and use the first one, or the third one, sorry. So that means we're going to use the 1 minus, or actually it's the other way, right? That one is 2 squared. Yeah, that's what that. So that one is, and then subtract 1 after that. So this one is 2 cosine squared of theta minus 1. So we know cosine, it's 3/5, and then we're squaring that, which we did from over here, right? It's 9/25. And then we're going to take 2 times that, and then we're going to subtract 1. So 2 times that is 18/25 minus 1. So that means we got to find a common denominator, which is 25/25. Subtract, we get negative 7/25. So cosine of 2 theta, or the double angle of cosine, is negative 7/25. And then tangent, so tangent, we could use the formula, tangent of 2 theta. We can use the formula, which is 2 tan of A, 1 minus tan squared. So we can use tan of A over 1 minus, 2 tan of A, minus 1 minus tan squared of A. But we don't know tangent. We could find tangent because we found sine and cosine. So sine was negative 4/5 and cosine was 3/5. So we can flip that. The 5s are going to cancel, right? So the 5s will cancel. This one's negative, so we get negative 4/5. So tangent of theta equals negative 4/3. And so then we can plug it into that formula. Well, we don't have to do that. You can do that. But we found cosine of 2 theta and sine of 2 theta, right? So we can use that. So we know cosine of 2 theta and sine of 2 theta. So when we divide these, we know we get tan of 2 theta. And we know sine is 24/25. Negative 24/25. Negative 24/25. And cosine is negative 7/25. So that is 24/25 negative. And then times by 25/7 negative. So negative times negative is a positive. 25s cancel out. We get tangent of 2 theta is equal to positive 24/7. So there's all 3 of our answers there. Okay, so here's another example. This time we're actually given what cosine of 2 theta is, or the double angle of cosine, is 4/5, right? And this lets us know that that's 180 and this is 90. That we're in the second quadrant. All right, so we're in the second quadrant, so that means sine is positive. That means cosecant is positive. That means cosine is negative. That means secant is negative. That means tangent is negative. That means cotangent is negative. Okay, so because we want to find all 6. Well, we're given cosine of 2 theta equals 4/5. Well, cosine of 2 theta is 1 minus 2 sine squared of theta. And we can see that from back here is 1 minus 2 sine squared of our angle. So I'm using that formula to then find sine, right? Because cosine of 2 theta is 1 minus 2 sine squared theta. So then I just solve this for sine. So here we're gonna we can subtract 1 both sides. So that'd be 4/5 minus 5/5. So we have negative 2 sine squared theta equals negative 1/5. And then we can multiply both sides by negative, or multiply both sides by negative 2. Negative 2. And that equals a 2/5 equals sine squared theta. Square root both sides. We get a plus or minus, but we know since we're in the second quadrant, sine is positive, so we don't need to worry about that. So sine is square root of 2/5. So sine of theta equals square root of 2 over the square root of 5. Rationalize the denominator. We get sine of theta equals square root of 10 over 5. Okay, so then we have found sine of theta. So looking at my answer here, I'm a little bit off when I check the book, and so I go back to my steps and I can say, hey, why did I multiply right here? Because if I multiply, shouldn't I get positive 4 here? So really I shouldn't have multiplied. What should I have actually done? We should actually divide it, right? So we should I should have divided, not you. I should have divided by negative 2, which is timesing by 1/2. So that actually equals a positive 1/10. So this is going to be 1/10. That's the square root of 1/10. 1/10. These are a little off. So that's the square root of 1 over the square root of 10. So that's 1 over square root 10, which makes cosecant square root 10, because I just flipped the fraction, right? And then here, to finally finish this, we're going to multiply by the rationalize it, right? So we get root 10 over 10. And then cosecant, we already flipped that fraction, so root 10 over 10. And now we can do cosine. Cosine we can do several different ways. We could use the cosine function as the formula, which is 2 cosine squared of theta minus 1 equals our cosine 2 theta, and our cosine 2 theta is 4/5. So we could use this, or we could use Pythagorean identity that says, hey, cosine of theta equals the square root of 1 minus sine squared of theta. So you could use that one as well. Anyone will do here. So here we add 1, so that means we're adding 5 over 5, which is 9 over 5, and then we're dividing by 2 this time. Make sure I do it right, which is timesing by 1/2, so that's 9/10. And then we got to get rid of the squared here, so we got to square root that. And then we know that cosine is negative because we're in the second quadrant, so we get the square root of 9 over the square root of 10. Okay, and square root of 9 is 3, so we get 3 square root 10. Now we can go ahead and flip it and get secant, right? Secant would be root 10 over 3. And we already know it's negative because it's in the second quadrant, so square root 10 over 3. And then we can rationalize our cosine, root 10 over root 10, which is 3 root 10 over 10. So there's cosine. We know it's negative because it's in the second quadrant, so that's negative 3 square root 10 over 10. And now we can do tangent. Tangent we can do a couple different ways, but we know we have sine, right, is root 10 over 10. And we know cosine is 3 root 10 over 10. So we flip the second one here. Oops. So we flip the second one, because when we're dividing by a fraction, we're multiplying by the reciprocal. So the 10s will cancel out, so will the root 10s. They will also cancel out. So we get 1/3. So tangent of theta equals 1/3. And we know it's negative because we're in the second quadrant. And then we can flip that for cotangent. Come on. Is 3. And we know it's negative because we're in the second quadrant. So this is negative 1/3. This is negative 3. So there we have all 6. So that's done for that example. Okay, so here we have a couple of quick examples of kind of going backwards and figuring out, okay, which double angle is it? Is it sine, cosine, or tangent? So we look at our formulas and we see that, hey, whenever we have cosine squared of an angle minus sine squared of an angle, that's talking about cosine of the double angle, right? So then here it's a double angle, right? So cosine of 2 times our theta. Well, what's our theta? Is what we're taking the cosine squared of, or the sine squared of 7x. So we multiply that. So we're finding cosine of 14. 2 times 7 is 14. 14x. Okay. This one we can look at, hey, which formula is this? A little bit different here, because it doesn't quite look like one. The closest one it looks like is 2 sine of theta cosine of theta. So what we need to do here is really there needs to be that 2 out in front. Well, how can I turn this 2 of the formula into the 1 that's in front of here? Well, I got to times that by 1/2, right? So in order to get this 2 to a 1, that 2 into a 1, I need to times it by 1/2. Right, so I'm going to need to multiply that by 1/2, and then it will look like it, right? So then here, we can write, it's going to be sine, because this formula is sine, so we know we're going to have sine of 2 times our theta, which is sine of 2 times 15, but then we have this 1/2 out here, right? So then we have that 1/2 out here, and 2 times 15 is 30, and sine of 30 is 1/2, so we have 1/2 times 1/2, which is 1/4. So that's kind of figuring these out, kind of going backwards and using the formulas in order to find out what the double angle is. Okay, here's another one. We want to write sine of 3x in terms of sine of x. So we want to use our double angle formula in order to turn this into something just with a sine in it instead of 3 times sine. So this is sine of 3x. Well, sine of 3x, isn't that just sine of 2x plus x? So we can use our sum formula, that's adding the sum of 2 angles. So sine, so Sinbad arranged the date. He goes with coset. And then he thinks their signs are the same, and then he puts his brother with her sister, right? And then we can go ahead and use our, what we just learned, our double angles, and rewrite these. So we can rewrite this, sine is 2 cosine squared, sine of double angle is 2 times sine of x cosine of x. And the double angle of cosine we want in terms of sine, so we want to rewrite this one as 1 minus 2 sine squared x. Okay, and then we can bring down our times by sine of x here, bring down that plus sign, and this one is times by another cosine of x. So then here we have 2 sine x, and then cosine times cosine is a cosine squared x plus, and we can go ahead and distribute this sine x, so that'd be sine x minus 2 sine cubed of x. Okay, now we can go ahead and rearrange these. So we want to rearrange these. But before I rearrange them, I need to turn this cosine squared of x into sine, right? Because I want it in terms of sine. So this is 2 sine x times this cosine squared is 1 minus sine squared of x, right, by Pythagorean identity. Now I can go ahead and distribute that one. So distribute this 2 sine x to the 1. Sine x, that's sine x. And then minus 2 sine cubed x plus sine x minus 2 sine cubed x. Okay, so now I can go ahead and arrange these. We can put them together. And so the 2 minus 2 sine cubed x and a minus 2 sine cubed x is a minus 4 sine cubed x, and a 2 sine x and a sine x is a 3 sine x. Okay, so there it's in terms of just sine. So there's our simplified in terms of sine. So then we can go to turn to page 668 and work on these numbers 11, 15, 17, 19, and 29, working with the double angles. And so we can go ahead and start on number 11. Okay, so then we want to find sine of 2 theta and cosine of 2 theta, given sine of theta equals -5/7, and cosine is positive. Okay, so we can go ahead and use Pythagorean identity that says cosine of theta equals 1 minus cosine squared of theta, and then square root that, right? And we know this is positive because it says that cosine is positive. So we go ahead and square our, oh, that's supposed to be sine in here. So we go ahead and square sine, so that would be positive, right? 5/49, and then we're going to 49, and then we're going to take 1 minus that, and then we're going to square root. So I automatically just squared this, right, because it says cosine, or sine squared. And so this would be 49/49, common denominator, right? Subtract 5, that's a 44. So 44/49, square root that, that's the square root of the top, which is the square root of 44, and square root of bottom, which is 7. We know it's positive, so there's cosine of theta. So now we can go ahead and find sine squared, because sine squared of theta, or not sine squared of theta, excuse me, sine of the double angle of sine, or sine of 2 times theta, excuse me, is 2 sine of theta cosine of theta, because now we both have sine, which is -5/7, and now we have cosine, which is √44/7. You can times that by 2, so 44 times 5, and since this 2 is on the outside, we know that it's still going to be on the outside, but that negative's on the outside, so it's 2 times a negative, that's a -2, and then 5 times 44. I can really break that down because they're both on the inside, and this 44 will break down to 4 and 11, so I can actually factor out a 2, right, because this breaks down into a pair. So I can pull out a 2, so it comes -4 outside, because this 2 is coming out with this 2 already there, so that's -4. And then I have this 11 and that 5, so this is 55. Okay, and then it's all over the common denominator, which is 49. So this is sine of 2 theta is -4 times the square root of 55 all over 49. Now to find cosine of 2 theta, or the double angle of cosine, we could just use the sine, or we could use our cosine. Right, sine is 1 minus sine squared of theta, 2 times that, 1 minus 2 times sine squared of theta. Make sure you have those written down properly. So we know sine squared, we know, was +5/49. And now we got to times that by -2, and then we take 1 and subtract that. Right, so that's 1 minus 10/49. So that is 49 minus 10 all over that common denominator, which is 39/49. And then we can go ahead, and that is cosine of 2 theta. Because this one we don't have the square root, right? That's our double angle of cosine. Okay, and so that's what it asked for. So there we have our answers. Okay, so we're trying to find theta. Trying to find theta when cosine of 2 theta is -5/12, and our angle is in the second quadrant. Okay, so we're trying to find we're trying to find sine of theta and cosine of theta. Alright, so we're not actually trying to find theta, we're just trying to find what is sine of theta and cosine of theta. Given that cosine of 2 times theta is -5/12, well, we can use, just like the last one, we can use this for the double angle of sine, or double angle of cosine, sorry. And then so we go ahead and we can subtract 1 on both sides. And subtracting 1 is just like subtracting 12/12. I'm subtracting, so -5 minus 12 is a -17/12. And then instead of timesing by 2, we're going to divide by 2, right? Try to not make the same mistake twice. Dividing by 2 is the same as multiplying by 1/2, and it's going to be a negative. So then we get rid of that negative. So we get sine squared of theta equals +17/24. Then we can square root both sides. So that's the square root of 17 over the square root of 24. So that's sine of theta. You can go ahead and break down that 24 to 8 and 3, and then 4 and 2 and 2 and 2. So then we can pull this out, a 2 out, and we get square root 6. And on top we have square root 17. Then we can rationalize multiplying by root 6 on bottom and on top. So 17 times 6 is 102. So sine of theta equals square root of 102 all over, so 6 and 6 makes a pair, so 6 comes out, 2 is already out, so that's 12 over 12. So there's sine of theta. Okay, now cosine of 2 theta, cosine of 2 theta is also equal to cosine squared of theta minus 1. So 2 times cosine squared of theta minus 1. And so we know cosine of 2 theta, that is 4/5, right, on number 15? No. Negative 5/12. So that was the example. Negative 5/12. So that will equal 2 cosine squared of theta minus 1. We can add 1 to both sides. That's adding 12 over 12. 12 minus 5 is 7. So 7 over 12 equals 2 cosine squared of theta divided by 2, which is multiplying by 1/2. So we get 7 over 24. Cosine equals cosine squared of theta. We can square root. So we get the square root of 7 over the square root of 24, which is the same as 2 root 6. Cosine of theta, we can rationalize. So we get square root 42 over 12 equals cosine of theta. And so that is number 42, or not 42, there's square root 42. Number 15, except for there's a negative here. Negative here because we're in the second quadrant. So that is negative. And sine was positive because it was in the second quadrant. Okay, so there is our answer for number 15. Now number 17. Okay, so here we're trying to find, we're going to rewrite these and find, we're going to use basically the identity to rewrite these, to go ahead and solve these. So this one we look at, okay, which double angle does this represent? That represents cosine of 2 theta. So it's cosine of 2 times our angle, and our angle is 15. Okay, so the 2 times 15 is cosine of 30, and cosine of 30 is root 3 over 2. So there's our answer, number 17. So now we can do number 19, and it's 1 minus 2 sine squared of 15. And so that also is cosine, right? So that is also cosine. So cosine squared of theta is equal to 1 minus 2 sine squared of theta. So our theta is 15. So we're going to have to take cosine of 2 times that angle, which is 15. So that is 30. So we get cosine of 30 once again is root 3 over 2. So there's our answer to number 19. So then we can go ahead and do number 25. And number 25 is negative 1/4. This is a little more tricky here. Squared of 47.1 degrees. Okay, so here it kind of looks like the last answer said 1 minus 2 sine squared of our angle is cosine 2 times theta. So this looks similar to the last one, except for we need to change 1 into 1/4, and we need to change 2 into 1/2, right? So what do I need to do to change 1 into 1/4? Well, that means I basically need to divide by 4, which is timesing by a quarter, right? If I times these each by a quarter, so a quarter times 1 would be a quarter. A quarter times 2, 2's would cancel with this 4, right? And you'd get and you get negative 1/2, and that's what I'm looking for up here, right? 1/4 minus 1/2 sine squared. So really, I can rewrite this one is multiplied by 1/4. I would distribute 1/4. Okay. So you got to figure out what do I times my normal formula by to look like the equation that I'm given or the expression that I'm given. So I'd have to multiply it by 1/4. So I'd have to multiply this by 1/4. And if I distribute that, I would get back to the expression that they gave me, right? So that means I got to take 1/4 and multiply it by this side. Right? I got to times this by 1/4. So then it would be the same, right? And so now I know my angle, it's right here. So 1/4 times cosine of 2 times my angle, which is 47.1. Cosine. Okay, so I'm going to take 2 times 47.1. So I times that by 2, I get 94.2. So cosine of 94, not 49, 94.2, and then I'm going to times that answer by 1/4. So this I have to do on my calculator, right? So I take cosine of 94.2, but I need to make sure that I am in degrees, right? Because this was in degrees, our original one's in degrees, and so that is negative 0.073-ish rounded, and then I'm going to times that by 1/4. So I'm actually going to enter this just like this on my calculator. Okay, and then I get my answer as negative 0.018 approximately. So that would be my answer to number 25. It looks like in the book they just leave it like number 25. They just leave it like this right there. Okay, so that's how you do the double angles. I'll do another video about the half angles.